Hey, I'm Nathan, CEO of Rendered.ai. Our mission at Rendered.ai is to reduce the time and cost required to produce effective synthetic data, which is helping us address some of the world's most difficult computer vision problems. It's a really interesting time to be in this space, right? We're developing technology for AI, but we're also developing technology with AI at a time that everything's exploding and it feels like the world is changing. In that period of uncertainty, we thought it'd be kind of cool to talk about the actual people that do this work and where they actually find these tools and decide what tools to use. So in that vein, we're just going to do a few discussions here with some of our engineers and get into specifics, right? What are we doing? What are we seeing? And where's it all headed? So with that said, I'd really love to introduce Matt Robinson, one of our best engineers. Matt, would you mind saying hi and telling us a little bit about yourself?
Yeah, sure. My name is Matt Robinson. I've been working with Rendered.ai for about 3 years now. My career has been focused in AI since I got my master's degree in information theory. I have been specifically in building AI apps for 7 or 8 years, and it's been really exciting to move into the computer vision space and generating synthetic data.
And Matt, I mean, you've been lead for us on a number of really killer projects. I mean, everything from detecting methane in the upper atmosphere and working with Planet to, things like X-rays and all sorts of wild physics and synthetic data. So it's exciting to have you here. Um, can you tell us a little bit about, so today we're going to talk a little bit about text to 3D and image to 3D tools and how we've used them. Can you tell us a little about the project that we're going to talk about today and where this came up most recently?
Yeah, the project that kind of spurred this on was a classification project for marine oblique imagery. So we have a synthetic data channel that is built to create training and evaluation data for marine oblique imagery.
Awesome. And so as you were building this out, what was missing in the ability to produce synthetic data for this capability?
Well, we didn't know at first, so we kind of threw in all of some models that looked like they were going to be what we needed, and
Some
after
3D models, like 3D models that we could do
this,
renderings of and simulations of. Yeah.
yeah, that's right. Like we were using a 3D renderer for this, and we were using Blender,
Mhm.
and so we had models that looked like they were sufficient, and after going through the initial zero-shot analysis, we discovered that the sailboat models were not producing images that were working well with the classification model.
And so, in that vein, what would you normally have done, like before you have access to AI producing image to 3D and text to 3D tools? Like, what would you have done historically?
Yeah, so our pipeline has typically been to go to Sketchfab or TurboSquid and buy some models and go through the painstaking process of making sure that all of their textures are lined up and the scale is set up so that we can use them on the platform.
Yeah. And what did you do this time?
Well, now this time, the text to 3D tools and images to 3D tools are to the point now where we could actually use them for the objects of interest. The technology is moving pretty fast, and so we could just go and tune the text prompts and together with uploading images of the examples from our training set and get several models that augmented our existing sailboat models and improved the accuracy.
And which tools specifically did you use?
Oh yeah, this one was Trellis. There's a couple on Hugging Face now that we are keeping our eyes on.
Yeah, it's exciting to see that happen. But in this case, yeah. So we went to Hugging, like literally, we went to Hugging Face. We uploaded some images, we put in some texts, and we were able to then ingest those models into a synthetic data pipeline.
Yeah, that's right. I think typically it would take a few days anyway for our 3D artists to come up with models and could do the iteration on this. And this took
Yeah.
about yeah, say hours instead of days,
That's nice.
for sure.
So we took a process that was days, and I mean, in my experience, finding the 3D artist, tasking, making sure the quality's there, getting it, that can be weeks, and turned it into a matter of hours. And then what happened? Did it work?
Yeah, that was our lowest performing class, and it came all the way up to the performance of our aircraft carriers and other objects that were working well.
That's wild. That's wild, right? I mean, we're using artificial intelligence to generate imagery to generate 3D models that we then put into a physics simulator that we can then use to train the AI to be better. Really cool.
Yeah,
Where
and it
do you think?
yielded, so that yielded, I think we had about a 60%, 65% accuracy on real data using the synthetic data based on the Trellis object models.
Cool, cool. I mean, good bump from starting with almost no data. So that's
Yeah,
always exciting.
I would still call that zero shot.
Yeah. So, I mean, yeah, 65% with completely zero shot is hard to do in a lot of these. Where do you see the technology going?
Right now it seems that the textures are missing. It worked out pretty well for sailboats because they're white,
Mm.
but it would be great to get to a point where some
And you mean
defect
like
could be
physics-based textures,
controlled.
right? Like we get a color, but we don't get like detailed physics knowledge of the
Yeah, that's right. I mean, they're really just painted straight colors that are coming out of these things at this point. And
so like PBRs are an important thing. Yeah.
yeah, so that's definitely a weakness that I see as being pretty fixable. Now that the geometry is really coming up. I mean, I was also playing with Hunyan lately, and and you can just upload an image, and it comes back with basically all of the geometry that you need. So we can still do that last layer of adding the textures, but it'll be great to see the 3D models with the AI generated objects fill in that gap.
Awesome. Well, Matt, I appreciate you taking time today. For those of you, joining us, we're going to continue to do these things because I think what we're seeing is that through model generation, through accelerated physics, through agentic workflows that make a lot of this automated, we are very rapidly moving from it taking, weeks to months to produce effective synthetic data into hours. And we want you guys to join us for the ride. It's pretty exciting. Thanks for being here. See you next time.